Hello. I am Chasm. I am founder of CodeWith, Chasm.com. This course explains how to work with sequence and time series data for regression tasks using long short-term memory, LSTM, networks. LSTM can be used for classification and regression, but the main focus in this course is regression. Because you must know the regression for time series prediction. Let me start with the LSTM network at the beginning. Humans don't start their thinking from scratch every second. As you watch this course, you understand each word based on your understanding of previous words. You don't throw everything away and start thinking from scratch again. Your thoughts have persistence. Traditional neural networks can't do this, and it seems like a major shortcoming. For example, imagine you want to classify what kind of event is happening at every point in a movie. It's unclear how a traditional neural network could use its reasoning about previous events in the film to inform later ones. An LSTM network is a type of recurrent neural network, RNN, that can learn long-term dependencies between time steps of sequence data. Long short-term memory network is an advanced RNN, a sequential network, that allows information to persist. It is capable of handling the vanishing gradient problem faced by RNN. A recurrent neural network is also known as RNN, is used for persistent memory. LSTM network architecture. The core components of an LSTM network are a sequence input layer and an LSTM layer. A sequence input layer inputs sequence or time series data into the network. An LSTM layer learns long-term dependencies between time steps of sequence data. This diagram illustrates the architecture of a simple LSTM network for classification. The network starts with a sequence input layer followed by an LSTM layer. To predict class labels, the network ends with a fully connected layer, a softmax layer, and a classification output layer. This diagram illustrates the architecture of a simple LSTM network for regression. The network starts with a sequence input layer followed by an LSTM layer. The network ends with a fully connected layer and a regression output layer. We got familiar with some LSTM architecture. Now we learn how to implement these network in MATLAB. For the implementation of a network in MATLAB, you must define the layer of your network in an array called layers. For example, in this slide, you can see how to define a classification LSTM networks. To create an LSTM network for sequence to label classification, create a layer array containing a sequence input layer, an LSTM layer, a fully connected layer, a softmax layer, and a classification output layer. These are the layers of an LSTM network. It is started by the sequence input layer. The input of this layer is the number of features. Set the size of the sequence input layer to the number of features of the input data. In this example, the number of features is 12. The next layer is the LSTM layer. For the LSTM layer, specify the number of hidden units and the output mode last. In this example, the number of hidden units is 100. Set the size of the fully connected layer to the number of classes. We are writing a classification LSTM, so we must define the number of classes. You do not need to specify the sequence length.